Hey guys, we're going to talk about glycolysis. The first step of glycolysis is glucose goes and turns into glucose 6-phosphate. This first step is metabolically irreversible, meaning that energy is required for the step to begin. We have kinase, hexokinase, 1, 2, and 3, glucose kinase. These are used to make glucose not glucose anymore. The second step of glycolysis is the transformation from glucose 6-phosphate to fructose 6-phosphate. This is a near equilibrium reaction requiring zero energy. It is done with a concentration determinant isomerase. The third step of glycolysis is two steps actually. We have a step that will end the glycolysis cycle, in which fructose 6-phosphate is transformed into fructose 2,6-bisphosphate. The other step in which glycolysis can proceed is fructose 1,6-bisphosphate. This is a metabolically irreversible step. It is considered the first committed step of glycolysis. It is also requires energy, so it has a negative delta G. A lot of inhibitors, such as ATP, glucagon, citrate, can cause this reaction to go backwards. Glucagon is the most recognized inhibitor that pushes back mass action, and the citrate that is used to inhibit this reaction comes from the Krebs cycle. The fourth step of glycolysis makes two products. Both products are used to proceed with glycolysis. One, it requires 2 steps to proceed. The other, it requires 1 step to proceed. It makes bisphosphate glyceraldehyde and also a dihydroxyacetate. These products are both used. One is glyceraldehyde 3-phosphate, the other is dihydroxyacetate. Glyceraldehyde is automatically transformed into bisphosphate glycerol. However, dihydroxyacetate has to go through another step. It has to rearrange to become glyceraldehyde, and then it can become bisphosphate glycerol. The 7th step of glycolysis is also a step that requires no energy. It changes the BPG into 3-phosphoglycerate using a kinase. The 8th step of glycolysis is the transformation from 3-phosphoglycerate to 2-phosphoglycerate. This is also a step that requires no energy. The 9th step of glycolysis is the transformation from 2-phosphoglycerate to phosphoenolpyruvate. This is also a step that requires no energy. It is a step that produces a product that has 2 times the amount of energy as ATP. The 10th step requires energy, and this is because transforming phosphoenol pyruvate into pyruvate is a very energetically heavy process due to the large amount of energy produced by phosphoenol pyruvate. This step produces 2 net ATP from the whole process. What is fun about this soap is it also contains glycerins, just like glycolysis, and since glycolysis produces 2 molecules of ATP, or free energy containing molecules, and 2 high energy electron carrying molecules of NADH, and also 2 molecules of pyruvic acid each cycle. This energy is used for things such as digestion, moving, even being able to consume more energy is something glycolysis helps with. It plays a big role in metabolism and many other bodily functions